Hi, my name is Mr. Chen. I welcome you to my study room. If today is your first time, then kindly consider subscribing to this channel for more videos. Today's study is going to be about the length of a tangent from an external point to a circle. And before we were able to do this, there are a few steps we need to take. So let's take those steps very quickly before we move on. Alright, so the steps are: 1. Identify the center AB and the radius r of the circle from the equation given. 2. Draw a tangent from the given external point to the circle and from the point to the center as shown below. Alright, so that is the diagram here, and we have that this is the point, external point. We've drawn to the circumference of the circle and we've drawn to the center of the circle, forming a right angle triangle. Let me call here D so that it will be right angle triangle PCD. Good. Then from Pythagoras theorem, D squared will be equal to L squared plus R squared. Remember, this is the radius of the circle, so I decided to call it R, and the length L, and then the distance between the center and the point D. And L squared will be equal to D squared minus R squared. But from the distance formula, the link to which I'm sharing with you at the top here, D squared will be equal to x minus a all squared plus y minus b all squared. So from that, L squared will be equal to, we substitute this one in place of D squared, so x minus a all squared plus y minus b all squared, and the whole of this minus r squared. Remember, we found r already from the equation of the circle according to, or the first point in the steps. Then because we are looking for the length L and not L squared, our L will become the square root of x minus a all squared plus y minus b all squared, and the whole of this minus r squared. And when we substitute the center of the circle, the coordinate of the point, and then the radius of the circle into this formula, is going to give us the length of the circle. So we take one example to see what we'll be getting. Example 1 says, find the length of the tangent from point A with coordinate -3, 2 to the circle x squared plus y squared equal to 3 plus 2x minus 2y. By the steps stated above, we have to find the center and radius of this circle so that we can use it. So I'm going to do that. But even this one, the equation of the circle is not written well, so I have to rewrite it for easy calculation. So x squared plus y squared equal to 3 plus 2x minus 2y will give us x squared plus y squared minus 2x plus 2y minus 3 equal to 0. I just move each of these at the left hand side to the right hand side. Good. So from the equation of a circle, for those who might not know how to find the center and radius of the circle, I'm just sharing the link at the top right now. That will give us 2g equal to negative 2. Dividing both sides by 2, g will be equal to negative 1. And then also 2f equals 2. Dividing both sides by 2, f will be equal to 1. So the center of our circle is negative g, negative f, which will give us 1, negative 1. Then we go ahead to find the radius of the circle. Then again, I already have a video on that, and r equals the square root of g squared plus f squared minus c, where c is the constant term of the equation. So the radius of our circle is negative 1 squared plus 1 squared minus our c is negative 3. And this should give us 1 plus 1 plus 3. And this will be equal to roots 5 units. Now that we have the center of our circle and the radius of the circle, we are just going to fix it into this formula here, and then we use it quickly. So by that, our L equals the square root of x minus a all squared plus y minus b all squared, and the whole of this minus r, which is the radius, squared. Good. Then don't forget that in this new equation we've written, this is our a, this is our b, the coordinate of the center of the circle. Don't forget this diagram here. This diagram here, we are using this as x, y, a and b, so don't forget it. So this is our a, b, and this is our r, and the coordinate of our point negative 3, 2 becomes our x and our y. So let me even write it closer to what I'm doing. So again, the center of our circle will be a, b, and then here will be x, y, the coordinate of the points outside the circle. And let me just quickly add our r, which is square root of 5. That means our L now becomes the square root of our x is negative 3 minus a is 1 all squared plus our y is 2 minus b is negative 1 all squared, then the whole of this minus r, which is root 5 also squared. And this gives us the square root of, this is negative 4 squared plus 3 squared. Remember, the whole of this minus root 5 squared will give us 5. So by working it further, we are going to have the square root of 16 plus 9 minus 5. Remember, together, the whole of this together minus 5. And this will give us the square root of 25 minus 5, which will be root 20, and is the same as 2 root 5. units. And this is the length of the tangent joining that point to the circle. We take another example, and with this example I would like you to pause the video and work it out, and then I will share the answer. So example 2 says find the length of a tangent from P with coordinate 8, 2 to the circle with equation x squared plus y squared minus 4x minus 8y minus 5 equals 0. Like I said, you should pause the video and work it out. And if you work it out well, your answer should be the square root of 15, which may be, for those who would like to change it to decimals, 3.87 units. That will be the length of the tangent joining this circle and the point P. And this is what I would like to bring today's study to an end. I hope it has helped your understanding of the concept you want to try. If yes, why not consider subscribing to this channel for more videos and also hitting the notification button so that anytime I upload a new video you'll be notified. Before I end, I must state that I have more videos on other things related to the circle, like finding the center and the radius, finding the equation of the circle and other equation of the tangent to a circle, the gradient of the tangent to a circle, and other things. So I encourage you to watch those videos to have a better understanding of the circle as a topic or concept. Thank you once again for making time with me in my study room, and I hope to see you again. Bye bye.